The last video from section 3.4, partial fraction decomposition, is once we factor out the denominator, is not going to be in a linear factor, meaning x minus 2, x plus 1 form. It's going to have a polynomial like x squared. So for example, this one, we have dx over x cubed minus 8, which is a difference of cube because 8 is 2 cubed. Apply the formula, we got x minus 2 and x squared plus 2x plus 4. We cannot further break down the x squared plus 2x, so we have to keep it like that. Then the numerator for the x squared plus 2x plus 4 is going to be bx plus c. So we always keep the numerator 1 degree less than the denominator. And then for the numerator, the original numerator is the invisible 1. Well, equals to, for a term, x over x minus 2 is missing x squared plus 2x plus 4. So I need to multiply that by a. And then for the x squared plus 2x plus 4 is missing an x minus 2. So I need to multiply x minus 2 by the bx plus c. Still the same thing, I do not want to multiply them and solve them regularly, so I'm going to pick x equal to 0. This is just purely random number. I always like to pick x equal to 0, negative 1, or 1 because it's easy to calculate. So I got 1 equal to a times 4 plus b times 0 plus c times negative 2. I think I made a mistake originally because x equal to 0 is the easy one to pick, but I want to eliminating both variables. So I'm going to pick x equal to 0 later. I'm going to start with x equal to 2 first because I want b and c to be eliminated. I can calculate 8. So I'm going to let x equal to 2. So x minus 2 will equal to 0. In this version, I'm able to eliminate b and c at the same time. So I got 1 equals to 12a, a equal to 1/12. Now I'm going to let x equal to 0 and also a equal to 1/12. In this version, I'm able to eliminate b and plug in a equal to 1/12. And I got 1 equals to 1/3 minus 2c. 4 over 12 is 1/3. So doing some simplification, subtractions, I got c equals to positive 1/3. Or negative 1/3. Because 1 minus 1/3 is positive 2/3. So I got a equal to positive 1/12, c equal to negative 1/3. And the next thing I need to figure out is what is the b. And at this level, I cannot really pick anything to make the problem a little bit easier to work with. So I'm just going to random pick x equal to some number. Again, I mentioned I like 1, 0, or negative 1. So here I'm picking x equal to 1. Plug in a equal to 1 over 12, c equal to negative 1/3, and finding the b. One equal to 7 over 12 plus or minus b, because 1 minus 2 is negative 1. Negative, so it's become to plus 1/3. 1/3, I can rewrite it as 4 over 12 because they have the denominator 7 over 12. And I got 1 equal to 11 over 12 minus b. So b is equal to negative 1/12. Now I calculate my a, b, and c. I can plug everything back into my setup to find the antiderivative. Okay, so the antiderivative of the dx over x cubed minus 8, because x cubed minus 8 can be factored as x minus 2 times x squared plus 2x plus 4. So the setup is going to break it up into integration of a over x minus 2 dx, where a is 1 over 12, plus integral of bx plus c. b is negative 1/12, c is negative 1/3, so negative 1/12x minus 1/3 over x squared plus 2x plus 4. For this one, the first part is easy to calculate, which is just the ln. But the second part, we need to work something. So first thing first, let's just simplify it so we do not have any fractions. So I'm going to factor out 1/12. So I ended up with x plus 4 over x squared plus 2x plus 4. The u substitution does not work. So we're going to rewrite the denominator as x plus 1 squared plus 3. And in this version, we can let u equal to x plus 1. Then x is equal to u minus 1, dx is equal to du. So the problem becomes to antiderivative of u minus 1 plus 4 over u squared plus 3. And we can break it as u over u squared plus 3 and the 3 over u squared plus 3. We can only break the numerator when they are doing addition, but not the denominator. The first part, because we have u on the numerator, we can just do another substitution. So we ended up with 1/2 ln of absolute value u squared plus 3. But the second part, we have to using the formulas, which gives us 3 over square root of 3 tangent inverse of u over square root of 3. Replace back with x. And that is our final answer of this antiderivative is 1 over 1/12 ln of x minus 2 minus 1 over 12 of the one we just calculated, 1/2 times ln of absolute value x plus 1 squared plus 3 plus square root of 3 times tangent inverse of x plus 1 over square root of 3.